Hello. So we're going to start talking about section 1.2, data sampling and variation in data and sampling. I'm going to split this up into a couple ones. So I'm going to try to keep these short. I think that will work better. Maybe this is a good moment to remind you, I would love feedback on any of these things, what's working, what's not working, what's helpful, what's not helpful, all that kind of stuff, since this is a new experience for most of us. Anyways, so we're going to focus on talking about data right now and the kinds of data that there are. So it turns out, right, not all data is the same, and we're gonna start dividing data into different categories. So the first big split that we're going to make is between, so let's put a little title on this, 1.2 data, sampling, and variation in that. Okay, so when we get data, there's going to be two big kinds of data that we'll talk about. There is going to be qualitative and quantitative. All right, so we can split our data into these two categories. Qualitative data are descriptions. Sometimes we say they're categorical. And then quantitative data are counts or measurements, right? We might say these are going to be quantities or numerical data. Okay, so let's just do a couple of quick examples, right? So for instance, let's say we were doing a doctor maybe is surveying patients about a procedure, and they often ask people to rate pain, right? So you might have a qualitative rating system. This might be something like a scale that goes from none to extreme, right? So you might have no pain, mild pain, some pain, extreme pain, or whatever words they give you to describe, right? That's qualitative, it's descriptive. You're fitting into a category versus quantitative, right? You could rate the pain from 0 to 10, right? So you're putting a number on how much pain you have, right? And so depending on the kind of data you have, you might be able to, you're able to do different kinds of things with it, right? There's not a lot of computation we can do with qualitative. Usually all we can do is something like a proportion. 15% of people had extreme pain, 25% had some pain, 5% had no pain, and so on. Whereas with quantitative data, right, your numbers, I could average that data. There's other things we can do that we haven't learned yet, things like standard deviation that we'll learn later in this quarter, medians, modes, all these other sorts of things. So there's usually a lot more that we can do with quantitative data, right? We might do, let's do another one. Let's do a restaurant experience, right? So one qualitative scale might be something like rate the service, right, from poor, fair, good, and great. And a quantitative experience might be something about the cost, right, from 0 to however, oops, pardon me, move that up, So we're rating the service up here, and then quantitative would be rating the cost from 0 up to however high the highest, most expensive meal is, right? Again, we get things that are categories versus things that are numbers, okay? And notice that both of these, my qualitative data are still in an order, right? From no pain up to extreme, or the service is going from poor and getting increasingly good, increasingly better up till great service, right? Some qualitative data doesn't even have an order, right? So if I ask the class what their favorite brand of soda is, right, you'd be put into a category. But there's no order, right? I can't put an order on that. Or if I asked your favorite color, or what city you were born in, right? All of these things would put you in a category, but there's no way to put them in any kind of order like this data has. We'll talk more about that idea a little bit later. Okay, then let's do one more thing. This is a little bit dicier of a topic, a little bit more subtle, but let's see if we can give some examples. So when we have, let's start a new page. When we have quantitative data, we can divide it up further. Okay, and we can divide it into two different kinds of quantitative data: continuous and discrete. Okay, so let's give some definitions and then some examples. So continuous data, data can take on any given value in a given range of numbers. Okay, these are usually measurements. I'll give some examples in a second. Let's define discrete data and then compare the two. It's usually easier to tell these two apart in comparison. Discrete data can, data only take on particular values, not values between. These are usually counts or counting something, right? So let's do a couple of examples here. Let's start with something discrete. So for example, I might ask you something like pairs of shoes you own, right? That data is just going to be a number, right? You're going to get 1 pair, 2 pairs, 3 pairs, and so on, right? Maybe you decide you have a pair where you're missing a shoe and you want to call that a half. But even then, we can only take on particular values: half a pair, 1 pair, 1.5, 2 pairs, 2.5, 3.5. You can't have 2.3441 pairs of shoes, right? On the other hand, let's say something like, let's say I time you guys in performing some task, right? So I give you a computation and I time how long it takes you to compute it, okay? Right? So we can divide time up as small as we want, right? We're only limited by our measuring device, and so somebody might have 60 seconds, but you could have 60.3 seconds or 60.3344125 seconds, right? There's no limit to how small I can divide time up, or at least we don't think there is. We're not going to get into the nature of the universe too much in this course. So again, notice that this is something we counted, number of pairs of shoes. This is something we measured, right? Let's do another example. Discrete data might be the number of hairs on your head, right? This is going to come as some number. We count the number of hairs versus the weight of hairs, the weight of hair on your head, right? So again, weight we can divide up smaller and smaller and smaller and smaller, whereas numbers of hairs are just 1, 2, 3, 4, and so on, right? So it's a tricky topic. We will talk a lot about it this quarter. There is some places later where we're going to have to decide what kind of data we have, and we do different things. We treat continuous and discrete data differently. It's usually going to be pretty clear, right? And this idea of counting versus measuring. So counting is how many of something, right, typically, versus measurements are going to be like time lengths, distance lengths, weights, that sort of stuff, okay? Things that we have to measure, okay? So those are the two divisions of the qualitative data. So right now what we've got is, first, we divide data into qualitative or quantitative, and then if it's quantitative, we can split it further into continuous and discrete data. So let's do one more thing before we go. Let's just run through a few more examples. Let me share a different page. Where are my examples? Okay, so we did a little bit of this, number of hairs on heads, the weight of hair on students' heads, hair color. So what I'm doing with this example is we're gonna take a look and decide if each piece of data or each kind of data is qualitative or quantitative, and then if it's quantitative, we want to know if it's discrete or continuous. So we already did these two, hairs on student heads and the weight of hair on students' heads. These are both quantitative data. The first one is discrete. The second one is continuous. Then we talk about hair color. Hair color would be qualitative data. You get put into a category: blonde hair, black hair, brown hair, etc. Right? Favorite number, right? This is an interesting one. Depending on what you're doing with it, I think you can really think of it different ways, right? We don't really think of your favorite number. If your favorite number is 37 and somebody else's favorite number is 13, it doesn't really matter which one's higher. We're just being put in a category. But I guess technically speaking, we should call that quantitative data. And probably it's discrete. Most people's favorite number, I would imagine, are going to be whole numbers, but somebody could decide that their favorite number is 2.7741111403, and they could keep dividing up smaller and smaller. So I guess this would have to be continuous data. Weight of coffee, that is quantitative, and it's continuous. We're measuring it, right? So weight is something we measure. Your phone number, quantitative data, it's discrete. Phone numbers come in whole numbers. And then age of earliest memory, this is quantitative. And I would also call, this discrete. Most people give their age in whole years or maybe half years, but nobody I've ever heard will say something like, I have a child who's 2.7314 years old. Okay. So that is our discrete and continuous data, qualitative and quantitative data. We will do more with this and revisit some of these ideas as we move forward. And that's it for now.